What else are we asking ourselves? When should we keep an outlier? What should we be asking ourselves, David?
If this is a mistake or not?
Yeah, if it's a mistake or not. That's always your number one question. Is this point a mistake? If I don't know if it's a mistake, keep it. Okay, when in doubt, keep it. By the end of the lesson, they should have been able to identify if a point was an outlier or not. And they should have been able to determine if we remove or keep an outlier from a data set.
Obviously, learning to identify outliers in a math class is part of a bigger picture, and it's part of teaching students to be critical thinkers. And why is that such an important skill for a student to develop?
Sure. As students get older, they need to be able to think about their own thinking, and they need to be able to problem solve regardless of what situation they're in. So that's a lot of what we do as teachers. We teach students how to think about their own thinking and how to engage in difficult and complex situations. So they should be able to propose solutions and propose ideas and take what they're proposing and apply that to more difficult and complex problems.
One of the things you told me in a previous conversation we had is you wanted to, when you became a teacher, teach the way you wanted to be taught. Explain that.
It means being clear and concise and incorporating fun, and also keeping the kids engaged. So incorporating games and activities and all the different modes of learning, right? Speaking, listening, reading, writing, incorporating all of those things while keeping the kids engaged, but also getting to know your students and having a relationship with them while we're engaging in the content. Your standard deviation is going to decrease, your average is going to decrease. Do we know for a fact if these outliers are mistakes? No, they don't tell you that they're mistakes. Is it possible they could be mistakes?
Yes.
Yeah.
What's the biggest difference between your classroom and the classrooms you sat in as a middle school math student?
The biggest difference, I'd say, is the amount of discovery that we allow the kids to make. So when I was in school, it was a lot of direct instruction, and it was a lot of teachers giving examples, and we took notes on notebook paper, and we followed along with the teacher and what they were doing. And now it's very hands-off to where the kids have the learning tasks and they're doing a lot of the discovery themselves. And then we come back together and discuss what they discovered and what they found.
Something I heard you say to a student in your classroom was, I saw the light bulb go on. What does it mean to you when you say that to a student, and what do you see that it means to them when they hear you say that?
When I say it to a student, I'm telling them that I recognize that they understand what they're doing. They had a light bulb moment. They understand either where they went wrong, where they went right, or they understand what we're doing. And it is making sense to them. And I'm acknowledging to them, hey, like I can see that you understand what we're doing. From a student perspective, hearing it from me, they are getting that reassurance, they're getting that clarification of, hey, she can see that I'm doing something correctly or I'm headed in the right direction with my thinking.